Okay, next we have the selection rules. As we know that when an atom is excited, then electron move from lower orbit to higher orbit. Now during de-excitation, electron also move from higher orbit to lower orbit. But electron cannot jump from one energy level, like each orbit is divided into different energy levels, so electron cannot jump from one energy level to all other energy levels during this transition. There should be some rules, or there should be some restriction on this electron during this transition, and those rules are called selection rules. So I can define the selection rule like this. A transition of electron between two levels is possible only if certain rule called selection rule are satisfied. Now these selection rules are listed below. We have, I think, 4 selection rules, or 4 selection rules. Yeah, we will discuss each one by one. The first selection rule is selection rule for orbital angular momentum. Now this rule says that during transition, only those lines are observed. Only those lines are observed for which the value of L changes by plus minus 1. Like if we have two energy levels, one is orbital angular momentum quantum number L1 and the other one is orbital angular momentum L2, such that the change in L values, delta L, which is L2 minus L1, is equal to plus minus 1, then this transition is possible. These lines are observed. Electron jump from this state to this state, this state to this state. So this is the first selection rule. For example, I can say that electron jump from an energy level for which L value is 0 to L value is 1, because delta L, which is 1 minus 0, is equal to 1 here. Electron jump from a state energy level in which L value is 1 to an energy level in which L value is 0, because delta L is minus 1 here. 0 minus 1. Electron can jump from an energy level in which L value is 2 to energy level in which L value is 1, or from L is equal to 1 to L is equal to 2, because here delta L is -1 and here delta L is +1. But electron cannot jump from L is equal to 2, energy level in which the orbital angular momentum is 2, to an energy level in which electron orbital angular momentum is 0. Because if we calculate delta L, it's come out to be -2. It cannot jump from an energy level in which L value is 0 to an energy level in which L value is 2, because delta L, which is 2 here. So these transitions are not possible. This is called the selection rule for L. Next we have selection rule for total angular momentum. First I will say that the selection rule for spin. Selection rule for spin angular momentum. The selection rule for spin quantum angular momentum is given by this. Delta S must be equal to 0. Like electron jump from energy level in which the spin is 1/2 to an energy level in which the spin is 1/2. Because we have delta S, which is 0 here. Electron jump from an energy level in which the spin is -1/2 to an energy level in which the spin is -1/2, because delta S is 0. But electron cannot jump from an energy level from 1/2 to -1/2, because delta S here is -1/2 -1/2, which is -1. Electron cannot jump from an energy level in which the spin is -1/2 to an energy level in which the spin is 1/2, because delta S is 1/2 minus into -1/2, which is 1. So these transitions are not possible. This is selection rule for S. Next we have selection rule for total angular momentum. Selection rule for total angular momentum. Now the selection rule for total angular momentum is delta J must be ±1 or 0. Like the value of J changes in such a way that the difference should be either +1 or -1 or 0. But transition from 0 to 0 is excluded. Like electron cannot jump from a state in which the total angular momentum is 0 to a state in which the total angular momentum is 0. This is excluded. From this we also get delta J is equal to 0, but this is excluded. This is not possible. So this is the selection rule for J. Now next these are the 3 selection rules. Next we have the intensity rules. Intensity rules. Now whether an allowed transition is weak or strong is determined by this intensity rule. We can say that intensity rule or rules tell us about a weak or strong transition. Now the first intensity rule is transition for which L and J values, orbital angular momentum, total orbital angular momentum and total angular momentum J, changes in the same way. What it means, I say that delta L is equal to delta J. Both changes in the same way, like from both we get +1, -1. Transition for which L and J values changes in the same way are strong. These transitions are a strong transition. And transition for which the change in L is not the same as the change in Lj. I can say that delta L is not equal to delta J. Then this transition is called a weak transition. It's a weak transition. This is the first intensity rule. Next we have the second rule, intensity rule. Transition for which L and J increases. L and J increases. That is, L goes to L plus 1 and J goes to J plus 1. They are less intense. They are less intense. Then those for which L and J decreases. By decreases I mean L goes to L minus 1 and J goes to J minus 1. Then these transitions are less intense. And the third one is transition for which the change in L, delta L, is opposite to the change in J, delta J. Opposite means they are opposite to each other. Then this is called a forbidden transition. This transition is not allowed. So these were the selection rules. In the next section we will discuss the spectrum of sodium by applying this selection rule. Thank you.